there students, Dr. Shragi here, and I just want to have a quick little lecture just going over those last little couple pages that's about methane in particular. Remember, methane is natural gas. It's what a lot of homes use to heat their homes or heat hot water. I love to cook on a natural gas range. It makes that little blue flame that you see, and it's just a lovely way to cook. Methane is an important part of this spectrum of energy sources that we use in the United States, where we refer to it, of course, as natural gas. You probably know that chemically it is CH4. If you don't know, make sure you do on the test. One carbon atom attached to 4 hydrogen atoms. Molecule per molecule, it's actually 20 times more powerful of a greenhouse gas than carbon dioxide is, but it occurs in far lower concentrations. It runs about 1.8 particles per million right now in the Earth's atmosphere, which is what, about 200 times less than the amount of carbon dioxide in the Earth's atmosphere. But that still means it's an important component of the total greenhouse effect on Earth. Let's talk about the human sources of methane first. Now, your book says the most important human source is the raising of livestock. And what they're talking about here is the type of animals that we call ruminants, like cattle, sheep, and goats. These are animals that produce enormous amounts of methane in their digestive tract as they digest their food. The book tries to avoid using the word cattle flatulence here, but that's exactly what we're talking about. I love how the book delicately says that the methane is eventually released to the atmosphere out both ends of the animal. The truth is, most ruminant animals that are kept for agricultural purposes are not in a very healthy diet and so on, and they produce enormous amounts of methane that is released into the Earth's atmosphere. Your book says that the next biggest source is about emissions from rice paddies. Now, when you look at how we grow rice in rice paddies, it looks very charming and it's, you know, it's very bucolic and so on. But it is actually an environmental disaster because the wet soils that are in there underneath that the standing water that the rice grows in is full of a bacteria that produces methane. This is in fact the same thing as what is called swamp gas. Swamps have the same sort of problem where the soils that are under the shallow water are producing enormous amounts of methane. In fact, swamp gas is how methane was originally discovered, but that's a story for a different day. Now, your book also, when talking about anthropogenic sources of methane, talks about landfills. Bacterial processes in landfills add millions of tons of methane. I mean, the trash that you send to the curb is full of things like food and diapers and paper and stuff like that that gradually, very slowly decomposes under the conditions of a landfill, and that produces methane when the bacteria in the landfill consume the food and diapers and all kinds of things. And it's actually an explosion hazard. Landfills explode when methane builds up below the surface if there's a source of ignition, or if it's just the pressure building up in the methane pockets and so on. It's something that has to be managed. Now, in some modern landfills, they actually harvest the methane. You can see there's sort of a schematic diagram of how this works with the landfill. There are wells that penetrate into the landfill. They don't have to be very deep. It's not like natural methane, which is, you know, maybe a half-mile below ground. We're just talking a landfill here. The methane is collected through these pipes and taken to someplace to be used. Now, in this particular schematic here, they're actually using it at a brick factory that's nearby, where they can use the methane as a source of heat for cooking of for the firing of the bricks. It can be sold back into the natural gas distribution system. There are other ways it can be consumed. I mean, we still end up emitting the carbon, but at least it was used to do something. That would be in contrast to this methane just getting away into the Earth's atmosphere and the brick factory next door having to buy electricity to fire the bricks. But in fairness, I mean, a lot of times all they do at a landfill is just flare the methane off. They just burn it. They have wells into the landfill where they extract the methane just so that they don't have an explosion hazard, and then they just flare it off like you're seeing in these pictures here. It's kind of an amazing waste, but on the other hand, I don't know what the production rate of methane off of a typical landfill is as to like how much of the power for a brick factory can be extracted in this way. But all the information that comes in your book right here about methane is actually meaningfully out of date. Your book was written in the like from around 2005, it was published in 2008. There's a new edition coming out, which we might be able to adjust this, But all this information does not take into account the giant boom in natural gas production by fracking. And today, the biggest source of anthropogenic methane emissions is actually the fossil fuel industry itself. Now, anytime you're extracting petroleum or coal or anything like that from the earth, there's methane emissions. There's methane emissions from a strip coal mine or from a oil wellhead and things like that. But today, it's the production of natural gas that is the primary source of emissions in the United States. I mean, there's just miles and miles and miles and millions of miles of pipes that are part of the distribution system of the natural gas that we extract by fracking. And all of that system has leaks. I mean, what we're pumping back and forth between all these pipelines here is a gas. Any tiny little leak, it just gets out. And so, whether it's at the wellhead itself, or whether it is during the process of drilling the well, or whether it is someplace in the system, there's just millions and millions of points of failure here where there are leaks in the system. And the truth of the matter is, it just isn't economically possible to fix all these leaks. Methane is, natural gas, is cheap. We can't really expect these natural gas drilling companies to go and to identify and fix every leak. It's just not economically possible. The gas is not that expensive. In fact, it's even a bigger problem when it happens actually at the wellhead itself. In the fall of 2015, you might recall that there was a giant failure of a natural gas well just right on the outskirts of Los Angeles that was one of the biggest natural gas leaks in world history. Enormous amounts, comparable to the total the emissions by all the vehicles in California were leaking for several months out of that wellhead right outside the city, not to mention the health hazards posed by the methane itself and so on. This is a very complicated problem, and the thing is, all methane wells leak. The thing is, they're mostly out in fairly isolated places in North Texas and western Iowa and rural northern Colorado and places like that where people aren't really there. They don't know that the methane leaks are happening to such a great extent. Now, before we move on to the second half of this lecture, I want to actually just pose a couple quick questions here. There will just be some quick true-false type things. True or false? There's more methane in the atmosphere than there is carbon dioxide. Make a choice. Get a little feedback before we move on to question 2.